All right, welcome back. We've got another one. Keep it going. Continuous distributions, talking about PDFs and CDFs, and I'll explain what that is today. But before we go, did you guys hear about the guy that stole the calendar? Yeah, it was rough. He got 12 months. Prison. Okay. 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 Continuous distributions. In other words, we're going to be looking at what a PDF is and what a CDF is. Now, a PDF, remember, is a probability distribution function. Now, you guys wouldn't have done this before because maybe you wouldn't have known how to integrate back then. But if we've got a PDF and we integrate it between its endpoints, right? So between its start and its starting and its ending value, the probability of any event happening, or all the probabilities added up together, should always equal to 1. Okay, now that's what we're doing. We're taking a look at that. So we're also trying to look at, I guess, cumulative distribution functions and probability distribution functions and how they relate, how we move from one to another. And so just like my classic kind of diagrams, if I've got a CDF and I want to get to my PDF, I'm going to differentiate. So if I've got a PDF and I want to find my CDF, I integrate. Okay. So that's going to be helpful for us to kind of understand. So cumulative, we differentiate to get your PDF, and from PDF, you integrate and you get your cumulative distribution. Right. And remember, cumulative is the helpful one. It's slightly more helpful. Finds quartiles, median, finds quartiles, medians. Oh, I think I've just lost. I think my iPad just conked out. Maybe I should just wait it out and you guys just kind of chill there, or should I re-record this? If it comes on in a little bit, we'll continue. If not, I'll make another one. Okay, I think we're good. I think we're back. Yes. Okay, you can use that time to reflect about your life. Tell me what you think about your life. Like and subscribe. Comment below. That would have been a perfect opportunity if I had some sponsors. So if anyone out there is wanting to sponsor me, I will allow it. Okay, so again, that's just DDX. This is your integration. Okay. CDF to PDF is differentiate. PDF to CDF is integrate. So that's what I mean. Basically, if you got your CDF, it's your integration of your PDF. And sometimes they also call it capital F of X because it's like the primitive. So just keep that in mind if we're, I guess, for the notation. Okay. And again, integrating to find area under PDF is the probability, or in other words, it helps us if we use the CDF, which is the integration, it helps us to find the quartile. So in other words, if we want quarter 1, we're just trying to find where it is 0.25. That's a quarter. Quarter 2, or in other words, the median, it makes sense that your CDF should equal 0.5. Third quartile is 0.75, and the fourth quartile for your CDF is just going to be 1, which makes sense, right? Because that means we've accumulated everything. By the fourth quarter, we're done. We're completed all the probabilities. Now, let's take a look at how we might apply this. All right, now let's say, let your PDF be represented by the function fx equals to x on 32, right? And what they're saying is, they're saying that, okay, the values of x could be anywhere between 0 and 8. Now, what we want to do here is we want to calculate the CDF and verify that f of b, so in that case, this is b, isn't it? That's a, that's b, right? So that means when I plug in x equals to 8, that should be my total, it should equal to 1. So let's do that. First things first, let's integrate x on 32 dx. What does that give me? Well, that gives me x squared on 64 because the 2 comes down to the bottom. And there's that. Okay. There's my giant fx. So if I go f of b, which is I substitute 8, that's going to become 8 squared on 64. And it checks out. We're good. Just equals to 1. So that means we've done our CDF properly. It's all good. Now, this is where it all comes in handy. Find the median of the PDF. That means cumulatively, if everything kind of goes between, let's just quickly do graphically, there's 100%. That means cumulatively, it will go up. That means your median is going to be exactly at the 50% mark, wherever that is. Okay. So what we're going to do is 50% is essentially the same thing as a half. So that means a half should equal the same thing as my, what do you call that? That's your probability distribution. Oh no, as your cumulative distribution. Okay, so I'm going to let it equal half. That's to find my median, right? I want my cumulative to be half, or 50 out of 100, or whatever you want to call it. So again, solving here, times the 64 to the other side. Half of 64 is 32. 32 equals to x squared. And then all you need to do here is, I guess, let's just take the square root of both sides. And I'm just going to clean it up just a little bit. Your x score here is going to be the square root of 4 root 2. Okay, so slightly over 4. That's going to be your answer there. Okay, so your median is going to be around that 4 root 2 score. All right, done. That's it. I hope that helps, and I'll catch you guys in another video. I'll see you later.